Hi, and welcome back to part 2 of our 3-half video series on the ZombieVerter and the Toyota Prius inverter. I want to welcome back both of our viewers who have made it through part 1. In this second video, we're going to build on what we did in the first. So first, let's do a little quick review. And I promise you guys there will be no wire harness unwrapping of any kind in this video. So I hope to move a bit quicker, and this video is hopefully not going to be as long. So first, what we have here is we have this 4-cable superhighway connecting our ZombieVerter to the 3rd-gen Prius inverter. And each one of these 4 cables contains 2 wires, a white one for negative signal and a black one for positive signal. And these are the MTH, CLK, REC, and HDM whatevers. So this is as compared to what we would use CAN bus if that happened to be a Nissan Leaf inverter, and that's as much as I know about that. But this is the meat and potatoes of the entire operation. So in addition to these 4 cables, we also have a white and black pair of wires for redundancy, and this provides ground to our inverter. And then we also have 2 green wires coming from the inverter through now a 5-amp fuse, and this is our power, 12-volt power to the inverter. Right now we have a very primitive setup. As soon as we will turn on our bench power supply, we will start powering on the inverter. Okay, so right now we just have permanent power going to the Zombie. So on pin 56 we have 12 volts positive through a 1-amp fuse, and on pin 55 we have a black wire providing ground. Again, if I'm going quickly, it's because all this has been covered in prior videos. I'm just doing a quick review. So at this point, we can turn on our laptop, turn on our bench power supply. One thing though with the bench power supply is I always like to see what it's preset to. What I've noticed with these bench power supplies in my environment is gremlins always hit them and hit the knobs or brush against them, and this could easily be twisted from 13 volts up to something higher, like 60, and burn a fuse or worse, damage the Zombie. So I always like to just check it. You can preset voltage or you can preset the current, and we're just presetting the voltage to about 13.3 volts. This is our car battery. Okay, this simulates our car battery. So let me turn that off real quick. Put our leads back on here. We are also now using these bus bars. I do apologize about the angle. I want it kind of going across the table. I know that this might be hard to see, but I will explain as I make the connections to it. Okay, so now we turn on permanent power, and this is how we find the car sitting in the garage. This is how we find the vehicle sitting in the parking lot, our driveway, what have you. The Zombie is always getting permanent power. Disregard that it's also now providing permanent power to the inverter. That would not be the case. That part is just for testing purposes. Again, in probably in part 3, maybe at the end of this video, if we have enough time, maybe at the end of this video, we will add a relay to our inverter power and have the Zombie power it on only when appropriate. Okay, so let me set up my laptop here. And so at this point, we will see FairyLink network being advertised, and we would be able to connect to the Open Inverter software, aka the menu system for the Zombie. And we can see 2 parameters right now. One is like an erroneous voltage reading of what the inverter sees, and the other one is the temperature of the inverter's heat sink. Okay, what I want to do now is now that's what we covered in the first video. So now in this video, what I want to do is add the ignition on wire to this, and we're using just a white wire just because to have it stand out. I will turn this off. We are also using these individual connections on these pins, and that's for demonstration purposes. You wouldn't drive the car like this. And the white wire goes on pin 15, so it's the very first top pin on what we're calling the B connector. So this is A connector and B connector, and I think it's just a holdover from the old days. This is all one thing now, but just to make it easier to point you guys in the right direction, majority of our stuff, all but one pin, will be on the B connector during these video series, just keeping it simple. Okay, and then I'm going to go ahead and connect this. This has a 1 amp inline fuse, and it has a on and off button, and this simulates us putting the key in the ignition if you happen to have a keyed ignition switch, and then just turning it one click over to the on position on most of them. I know some ignitions might go off, accessories on, so you get the idea. And here I'm just going to put this on our second stud, just because we couldn't put them all on the first stud. We can pick any stud we want here. I'm just putting it on the second one. And I am curious to see if anything changes in our software. Okay, so all we did was just add one more wire on pin 15, that's ignition on. So here we go. We turn on our permanent power. So we are really not configuring anything, so we aren't really going into parameters. What we're interested in is the feedback that we're getting right now. So we are interested in spot values. Here we are under spot values. I'm going to scroll a little bit just so that we can see more of it. And now I am simply just going to turn on the ignition. So ignition is on, and nothing really jumps out at me that it has changed at this time. So the temperature of the heatsink is 21 Celsius. I wonder what that is in Fahrenheit. I need to convert that. I'm going to go ahead and connect more to our inverter. I'm going to connect the run or start, whatever we call it, wire as well. So bear with me here. And now I'm going to put this on pin 52, 56, 55, 4, 3, 2. There we go. And this goes on next stud over, just for fun. Okay. All right, so let's fire this up and see what happens. All right, so with our ignition wire connected and our start wire connected. Let's fire up our car battery here and see what happens if any new parameters update themselves in our Open Inverter software here. We have our Fairy Link. We go to our Hubner interface. We are going to refresh it. Okay. So I'm going to put it on auto refresh. And see if anything new pops up, really. So ignition on, and then start. And that takes us to op mode run. And inverter UDC is sort of misreporting -2 volts, what have you. That's fine. Then we go to temp heatsink is at 22 Celsius. The other thing that I'm interested in here is this INV stat. So it actually says inverter stat is on. That is cool. Let's turn off our ignition. Oh, this is cool. T15 stat. That is our essentially ignition stat. Let's turn that on. Okay, so T15 stat toggles on and off rather than the mode toggling. I'll be honest with you, I didn't catch that in the prior versions, so I don't know if that's a new thing or if that was always there. But again, I wish we could sort these and rearrange them because there's just so many parameters and it's so difficult to see them all as they're just kind of scattered in shotgun fashion on the screen here. But okay, well, that's cool. So we know there's this ignition T15 and we see that inverter stat is on. Let me turn off auto refresh and let me disconnect the ignition. Let's see, I want to see when the ignition stat changes to on or inverter stat changes to on. Let me disconnect that guy. Put that on auto refresh. So we're learning together here, okay? I'll be honest with you, we're learning together. Let me see. Okay, it's an auto refresh. Go to inverter stat, INV stat. So we're looking at this one. Okay, so turn off the ignition. Okay, so right now our ignition, T15 stat is our ignition on. That's just another way of saying that. And you guys, anybody in the States who has referred to ignition as, you know, T15 or whatever 15, I've never heard that before, just being honest with you guys. So, and let me know if you Europeans, if that's just common for you guys to know that that's T15. Okay, let's see if that inverter stat changes from off to on simply by giving that the power to the inverter. Yeah, that's exactly what it is. Okay, well, cool. Again, only criticism is that it's just scattered all over the page, and that's just the consumer in me talking. The the user. But we have 15 stat, so turn on our ignition and P15 stat turns to on. Love it. That's great. Let's go up here to mode, op mode, and we're going to press the start button. And op mode goes to run. Okay. So we knew about inverter UDC, which was inverter voltage, erroneously saying -2. Then we also noticed there was that temp for the heat sink, which is reporting 22 Celsius. And then we just discovered one additional inverter parameter, one that I should have mentioned in the first video, but I honestly didn't even see it. So inverter stat, it goes from on to off. That's awesome. All right, let's continue on with the video, and what we're going to do next is turn everything off, and then we're going to add another bench power supply to provide high voltage simulation to our inverter. So let's do that. Turn off the ignition, turn off this car battery. All right, guys, say hello to Big Bertha here. This is my new bench power supply. This is going to be first time using it. And I got this guy because it goes to 20 amps. So actually in the back here, it can provide 20 amps in the back and up to 10 amps using the sort of traditional front connectors. So what I've done here is I actually made some 2-foot long leads, and these are orange just to help us with our conceptual simulation that this is high voltage. And something I want you guys to learn me is, are high voltage orange wires color coded? I ask because I have a number of orange wires hanging on my wall back there, and some, both the positive and negative leads, are just solid orange with no markings. I have some where they're marked with a long white stripe and some that are marked with a black stripe. So the question is, are they color coded? Is high voltage color coded? Honestly, don't know. I've actually seen some that do have red tape on them that I didn't add. That's just how I got them from the junkyards or what have you. But anyway, on this, we're going to add here these leads to the back so that we can get up to 20 amps. Now, in this next test, we're not necessarily going to have a load, but I'm just kind of doing this for funsies here. I always like to just turn this thing on, make sure these leads don't touch. I just like to turn this on and see what our setting is at. Is this going to turn on? Okay. So it's at 13 volts. And is there a course? Let's see here. So this side is current. We're not presetting the current. We're just going to, so this is voltage, and this goes to 30 volts. So the nice thing about using a bench power supply is that we can hook it up to the inverter and we can limit the current. I'm going to just turn down the voltage and then crank it up. But I think even if we fed that inverter all 30 volts at 20 amps, it would be nothing. It's not going to blow up the capacitor because it's so low. But I'm still going to start about 10 volts and just crank it up. So I'm going to turn this off. And then I want to show you guys. So see this, just a reminder, okay? Let's go over this. So When doing an EV conversion using Lexus or Toyota inverters, we do not connect our high voltage to the standard input. So this is where the high voltage battery of the Prius would come in, but its battery pack is only 200 volts and we're running higher. We're going to run about 300 volts, maybe 350, maybe 400. So we don't use the standard OEM input. These two run to the motor. So this is the output to the motors. Well, you can think of them as output input if we're talking regen, but you get the idea. So this is DC, that's AC, AC. And then this is for air conditioning. So this is going to just get blocked off. But I just want to show you that we do not connect it here. I just happen to have a little stub here to demonstrate. What we have to do is we have to connect in the back here, tapping into the high voltage bus bars, or the high voltage bus, if you will. So these are color coded, and I also labeled them down here. Let me see what's the best way to do this. Maybe something to this effect. See if I can tighten those a little bit better. I think these are just 10 mils. Okay, so you guys get the idea. And then, so this is our high voltage simulation, right? So we have that set up. And then this. Okay, so now we're gonna fire it all up again and hope we don't get any black smoke. So this battery pack is simulating a car battery, and this Big Bertha, big battery, big bench power supply is simulating a high voltage input to our inverter. This is our high voltage battery pack right there. Okay guys, let's see if we see any additional parameters now with the high voltage battery pack simulation hooked up. So first we turn on our permanent power here. All right, so we go to spot values and we're going to turn out auto refresh. And first thing we're going to do is we're going to turn on our high voltage battery pack here. And is that saying anything? Okay. That should be at 10 volts. So I'm getting about 7 volts right now on the INV UDC. So I'm going to crank that up I'm going to crank that up to the max, and we see that it updates to 29 volts. There's always going to be a bit of a discrepancy with this kind of stuff, so don't get hung up on that. INVU DC is at 29 volts, and our bench power supply is reading, I think, about 32. So that's close enough. Our up mode is off. If we go down to our temp, for the heatsink of the inverter is 23. And then if we go a little bit further, so inverter stat is on, we know about that. And T15 stat is still off. We haven't turned that on. Let's go ahead and turn on our ignition. And then we're going to manually refresh. So T15 stat is now on. And then if we go to the top here, op mode is off, but if we press our start button, that should also turn to run. Let's manually refresh it. Okay. So IDC, I believe, is inverter current, but we have no load of any kind on this right now, so we're not pulling any amps, so we're not going to see anything there, I don't think. And so this might be as good as it gets. We're just seeing that this inverter UDC does read the voltage of the battery pack, and all we can give ours is, the max of the 30 amps or so. Well, maybe we can finish this video with wiring up a relay to finally power on the inverter via the zombie control. So I'm going to work on that next. Okay guys, let's wrap up today's video by adding a relay to the positive lead to the inverter. This will allow our zombie to turn the inverter off and on. And why is that important? Well, we don't have to do this, but it is recommended, and that is how I'm going to run it. I think it's more important that the zombie can turn it off than turn it on, but I think they're possibly both equally important. The zombie can sense certain conditions, and based on those, shut off our high voltage and shut off our inverter. I think the inverter may have some safety stuff built in for when things get really bad, and it will just shut itself down if things get too hot, for instance. But since this VCU is vehicle control unit, we might as well use it to control our inverter. So we will be adding another pin, and this pin is their first one and probably the only one that we'll use off of the A plug, and this is pin number 32, and it is called inverter power LS switch, or low side switch, and we'll talk about that in a minute. But we will be adding a relay, so we will be essentially adding a switch. This is what I call a human switch. It's controlled by a human. Off, on, off, on. Well, a relay is an electronic switch. So rather than a human switching it, electricity switches it. And I think of relays in two different flavors. The little guy is what I would call a logical relay, and the big guy is what I call a power relay. You can use the power relays everywhere, but what I mean by that is that these are both, let's say, 12-volt automotive relays. However, they differ in how many amps they can carry, how much current you can send through them. And these are also 4-pin. There are also 5-pin relays, and there are relays with up to number of pins. We are not going to be talking about any of those. We're just going to focus on the simple 4-pin relays. And the power relays are something that you would use to send high current to something like a radiator fan or a water pump. And so we will not be using high current relay for this. we're going to be using what I call a logical relay. And a logical relay is literally just the electronic switch, off, on, off, on. So for this one, we don't need 30 amps or 20 amps. This probably will pass like 1 or 2 amps through it. So when we have 4 pins, if we think about inserting a relay into our circuit, so this is our positive, and we can put this relay either on the positive lead or a negative lead to the inverter, okay? I'm going to add it to the positive. And just imagine you have a wire and you just cut it in half. So you cut it in half, and then a relay will usually have 2 bigger pins and 2 kind of skinnier pins. The bigger pins are what's going to carry your load, okay? And those pins, it's the same wire just cut in half. It's not negative and then positive. It's either all negative wire through it or all positive wire through it, let's say, right? And on some of the more powerful ones, the bigger pins are just kind of perpendicular to each other. But on this little guy, they seem to be parallel, but it's okay. And then with these two, maybe we can argue that it matters which ones you put the wires on, but I don't think it matters whether it's input or output. But so what we're going to do is first just insert a relay in between our wire or our circuit. And I've prepared just some more wire ends to make this insertion easy. Now, we still need to maintain a fuse, so we will do that. And so the fuse always goes, in my opinion, closest to the power source or closest to the battery. So here, this is a 5 amp fuse. So fuse, power comes in here through a 5 amp fuse and to the relay, okay, like so. And then it needs to come out of the relay and continue to the inverter. So please don't mind that I have another fuse on this side. That is not necessary. I'm only doing this is so that I can easily move my wire harnesses from different types of setups. So this is why I love these fuses, because they also act as connects and disconnects. But just pretend that this side doesn't exist. So we go like this. All right. So there's our relay inserted into the circuit. And just to demonstrate now, rather than a human clicking a button on and off, we just need to put a positive and negative on the 2 smaller pins, which I could call the control pins, and a switch inside of there will close the circuit. So I love using my little 9-volt battery as a demo here, because we can just connect them and it doesn't matter really which one's positive, which one's negative. But when I do that, it's too faint for you guys to hear, but I hear a tiny little click, and I also feel a little snap inside of this little relay. So when we apply positive and negative to these 2 control pins, it closes. That's my universal thing for throttle, and it's also for switch. So it's like open connection, closed connection, open connection, closed connection, right? Science, people, science. All right. So now we have a relay in here. And now how do we control it? Well, we know this needs positive and negative. All right, that's fine. So, but Damien tells us that the VCU is providing a low side switch.
We then come to these 3 signals here. Inverter power LS switch, main contactor LS switch, and pre-charge LS switch. So first of all, the LS is shorthand for low side. Low side means in this case that we are switching the ground of the device that we wish to control. Now, if you don't understand what that means, I'd suggest having a look around the web and or YouTube, and there's some very good descriptions of the difference between high side and low side switching of relays and other loads in an automotive setting. The inverter power low side switch is designed to switch a relay coil that then controls the 12 volt feed to an inverter, such as a Nissan Leaf inverter, a Lexus inverter, a Prius inverter, it's the other one I've been messing about with, the Mitsubishi Outlander inverter. So this signal here allows the VCU to control the 12 volt supply to an inverter, powertrain, and various components like that.
And that's just a fancy way of saying on the ground side, on the negative side, or it's sending a negative signal. So if negative comes from the VCU, that means the other pin must be positive. It must go to our positive bus bar. And if you don't know what kind of pin comes out of there, whether it's negative 12 volts or positive 12 volts, what you can do is just use a test light and get the lead from the pin and touch it to the negative. Okay, if you touch a negative to a negative, nothing bad's going to happen. If you touch a negative to a if that's actually a positive pin and you touch it to a negative bus bar, then you'll get a light. So then you'll confirm it. It's very crude, but it is what it is. So here we're going to put it on our next stud. We're going to add a positive lead to our logical control pin. And this also gets a fuse, but this one's getting a 1 amp fuse, whereas our load here got a 5 amp fuse. More current's going to flow on the green wire than it does on the red. And in practice, you would see a wire gauge difference or thickness difference. The wire that would run to the bigger pins would be lower gauge number. So like instead of being a 16, it would be like a 12 or a 10, thicker wire. Whereas the control wire could be something like a 22 gauge, really skinny, right? Again, I don't think it matters which pins for control these go on. So I'm just going to pick one. And now we have positive going to the control side. And now what we need to do is add another wire, which is our ground, but the ground is controlled by the VCU. So I'm going to put this on the other pin. I'll try to show a picture of how this is connected, because I know it's hard to see with this dinkiness here. Okay, so the yellow is really a ground signal here. And this is going to go on what I keep referring to as the A connector. Well, earlier I said we can pretty much drive the car just on everything on the B, and I said put an asterisk on it. Well, here's the asterisk. So this goes on the fourth pin over on the bottom row, fourth pin from the left. So that's number 32. It's number 32, like so. Okay, so now rather than the inverter coming on right when we turn on permanent power, it's not going to come on. I'm making sure that this ignition switch I turned off because I was playing with it. I know this looks like a complete disaster, but I hope you guys are following. Let me turn on the bench power supply here. All right, let's see if we have our network. Okay, we have FairyLink, so we jump over to our Open Inverter software, our web interface. We go to spot values, And let's see if we can turn on auto refresh. Okay, so what we're going to do here is we're going to go down to the section where we can see the T15 and also the inverter. Okay, so T15 stat says off and inverter status below it says off as well. Okay, so let me turn on the ignition. Okay, look at that. T15 stat is now on. Our ignition, we turn the key to on and it's on. But our inverter is still off. All right, so now we're going to turn the key further to the start or the run position. And look at that. The inverter stat changed to on. And just to prove to you guys that it is indeed the ZombieVerter that is controlling that relay, just close the switch, electronic switch inside that little relay or logical relay to the inverter. I am going to disconnect the yellow wire from pin 32. I know we shouldn't connect or disconnect stuff, but this is just for demonstration purposes, right? So here we go. As soon as I disconnect this wire, our inv stat should turn off. And there it is. Inv stat is now off. Okay, I'm not going to connect that pin while everything is on, but to me that satisfies my curiosity that indeed the yellow wire does control the relay, which does control the inverter. So this is the proper way to wire our inverter low side power. Notice I didn't even turn on the Big Bertha here to supply high voltage to our inverter. That wasn't necessary for this test. We are focused on the control side, the low voltage wiring for the inverter at this moment. And this is the end of our second video. There's more to come. I think in the next video, we will actually connect a BMW battery module to the inverter via the safety box. So I'll also add the BMW safety box or the contactor box, and I'll add 1 or 2 BMW actual battery modules. Each one of those is 60 volts. So we'll start off with maybe 60 volts, and who knows how many amps are in those things, a lot. And then maybe we'll add 2 for 120 volts going into the inverter. And we'll have almost what I would call the whole enchilada. But yeah, stay tuned. That's what's coming up in the third half of the inverter series. Thanks for watching, guys.